like that. The curves have to be relatively similar. So this mathematician, Levine, developed a formula in SPSS for us to test equality of variances. And the easiest way to talk about this is if the top row, if this right here is less than 0.05, I need to drop down to the bottom row. But this is not less than 0.05, so I do have equality of variances. The variances look very similar. There's something up here that if I was just looking at it, I could probably tell with my naked eye that that these curves look very similar. Does anybody want to take a guess at what it is? I'll give you 2,500 bonus points if you can tell me. Anybody want to guess? Bueller? Anyone? Look at the standard deviations. Excuse me, they're very similar, right? Is that what everybody was going to say? So the curves look very similar because the standard deviations, one's 11 and one's 10. The means are 24 and 14. The average number of mistakes for the REM deprived group is 24. The average for the control is 14. Do those two numbers look different to you? Yes. What is the null hypothesis? There's no difference. But let's look at the t-test. We come over here, the t is 1.910. The significance is 0.07. What does that have to be less than for us to say that that is significant and we reject the null hypothesis? What does that have to be less than? 0.05. But that is not less than 0.05. So what do we do with our null hypothesis? Anybody? Unmute.
Fail to reject.
Correct. And it's kind of trippy because even though those look like they're way far apart, they're not far enough apart for us to be certain that it's not just due to error. It's not just due to error. We always want that to be less than 0.05 in social and behavioral sciences. So good. So that's why this is really important, because we want to look at it and we want to run it through Gosset's math. Okay? I have 2 more tests to go over, ANOVA and correlation, but I've got to get some more ice water. Can we take 5 minutes? Or 10? Should we take 10? I'm going to go hack.
10.
10 minutes. Okay, I have 307, so 317. All righty, I will see you momentarily. Thank you. Oliver is still up. I have my Oliver right here.
Hey, Oliver.
Shauna, where are you in San Diego? San Diego.
I'm currently near UCSD.
Oh, wow. Okay. La Jolla or? Very cool. Beautiful. Beautiful area.
Yeah, we got really lucky.
Wow. I do the MS bike ride. It's called Beta Bay, and we ride from Irvine all the way to like SeaWorld in 2 days. It's 50 miles to Legoland, and then it's 50 miles from Legoland to SeaWorld, and it goes up through Torrey Pines. You know, that Torrey Pines grade right there, it's really tough. But then we're kind of on the backside of UCSD riding through there. It's a beautiful ride.
Do you ever go around Gilman?
I don't think I have.
We get a lot of bikers right around our street.
Okay.
Likelihood is if you go around here, we probably
Yeah.
at some point.
That ride is super fun. It's really fun. It's a good cause too. Boy, he's active.
Yeah.
That's
Today he
cute.
decided no naps, so we'll see how that goes.
How old? Let me guess how old he is, because my 26-year-old's right here. I would guess he is. I mean, I could be totally off. I would guess he's a year old. Is that right?
A little less. He turned 10 months yesterday.
Okay. Because I can't remember like anything about size or what they're doing.
Yeah, and he's not really listening to pediatrician recommendations, so I think he's a little difficult to stage just by looking at him.
Oh no, I just don't know. He could have been 3, and I wouldn't know. I don't. Okay, we're gonna have some entertainment here for just a minute. I have a couple of computers in my house. One is here, and then one's sitting right there. So, are there any Star Wars fans? No Star Wars fans? Any Avengers fans? Okay, Avengers fans.
Okay.
Okay, hang on.
By the way, did you guys hear about Avengers Campus opening it? I went to. I'm a cast member at Disneyland, and I got to go to the cast preview of it about a week ago. It's amazing. We went on the Spider-Man ride, and you guys are in for a treat.
Okay, so here's the first. So, Lowell, what was the last Spider-Man movie?
It was Spider-Man Far From Home. It was released in July of 2019, and I believe it was rated. Obviously, it's rated PG-13. All the Marvel Cinematic Universe movies are rated PG-13, and I believe it was PG-13 for violence, action, some suggestive humor.
When did you see it?
I saw it in July. I think it was, you know what? I saw it on the 4th of July of 2019.
What day of the week was that?
It was, okay.
All right. If not,
No, I got this. Hold on. Don't tell me.
we don't have time.
No.
You gotta be certain.
No. It was on a Thursday.
What is it? 2019?
Yes.
July 4th, 2019?
It was on a Thursday.
Hey, you got it. Okay. What was the last Star Wars movie you saw?
The Rise of Skywalker.
When was that?
It was December 18th. Don't tell me.
I'm not telling you.
Don't tell me. Okay.
You're a little foggy.
Okay.
Okay, when was Attack of the Clones?
No. Rise of Skywalker was December 16th, 2019. No way.
You don't have to tell me the date.
December.
So, okay.
And then Attack of the Clones was May 16th, 2002, Thursday.
Okay.
And that was PG-13 for sequences of sci-fi action violence.
Okay. Any other questions from the class on Marvel or?
Ask me questions on Marvel.
Emily, you got a Marvel question?
No.
Nicole, Marvel question?
Ask away.
What about, what's the other one? Indiana Jones? What was the last Indiana Jones movie?
Indiana Jones and the Last Crusade in 1989.
When did you see?
No, I just kidding. No, the Saturday Night Live sketch was Kingdom of the Crystal Skull, released in May 22nd, 2008. That was the one with Shia LaBeouf. Anybody remember him?
Okay, I got a lecture. Thanks.
All right.
Thanks, buddy. I love you.
I love you too.
All right, bye-bye. Can you go talk to Matt in my bedroom? Yeah. Okay. You can close up. All right. That was your entertainment. He's a little slow today. Normally he's like, does anybody know anybody with Asperger's? You do now.
Very, very intelligent.
Yeah. So, okay. All right, where are we? Okay, now what I'm going to do is we did a paired T, an independent T. Now I'm going to show you ANOVA, analysis of variance. Okay, so with analysis of variance, again, it comes from a business example. So there was, back in the old days, say we owned a tomato farm and we had tomato field A, tomato field B, and tomato field C. What's the first thing you notice about our tomato fields?
They're all different sizes.
Correct, they're different sizes. Okay, so say a fertilizer salesman comes to town and he says, hey, 508 from San Diego, you own tomato farm. I'm selling fertilizer. Want to try some different fertilizers? And we say, sure. And if we're tomato farmers, what type of tomatoes do we want to plant? Do we want to yield? We want great tomatoes, super great tomatoes. We, however you judge tomatoes, whether it's size, like overall quality, whatever it is. I don't think you have Bristol Farms down in San Diego, but we have Bristol Farms here. It's like Whole Foods. I think it's better. It's a great gourmet store. And I made hamburgers on Saturday night. I made gourmet hamburgers with blue cheese and all that stuff. And I bought tomatoes, and they were actually not the greatest tomatoes I've ever got there. They were a little bit overripe. But so we have a criteria at our tomato farm of judging tomatoes, and we give them a score from 1 to 10. And this fertilizer salesman says, hey, I'll give you nitrogen for tomato field A. I'll give you compost for tomato field B. And I'll give you, I don't know, fish heads for tomato field C. And we plant tomatoes. And then at the end of the year, we take a random sample of 30 tomatoes from each, and we rate them just like Gossett did, right? Well, the t-test only works with 2 groups. And so what people did once the t-test was developed, when you had more than 2 groups, they would do a t-test here, a t-test here, and a t-test here. But what ends up happening is that it doesn't really work out statistically speaking to do that. So another statistician came along, and his name was Fisher, with an F, Fisher. And Fisher said, you know what, I'll develop a statistical test to compare the difference between means when there's more than 2 groups. And it doesn't have to be 3, it could be 4 groups, it could be 5 groups, it could be 6 groups, it could be 10 groups. ANOVA will still work because he uses the variance as one of the critical components of his statistical formula. Remember when we computed the standard deviation, we actually got the variance right before we took the square root of that. And so Fisher uses the variance component to do his statistical test to compare the means of more than 2 groups. And his test is called ANOVA, analysis of variance. And so it's a great statistical test. So here's what we're gonna do. I know I have a vignette that I would like to show you. Where's my vignette? Okay, right here. Okay, another great psychology example. Sorry. Okay, so say you worked in a clinic and you are you want to test 3 different things. You have 3 different groups. One group has, I think this is 8 people in it, 8 people, and they come to you and say they have depression, right? Same thing, depression. And this group takes a pretest to measure their depression, and then they get counseling only. And then you give them a post-test, right? After they get counseling only. And then this is the difference of the pre-test from the post-test. A second group of people gets counseling and a drug. And these are 11 people in this group. So 11 people come, they get a pre-test, see how depressed they are, they get a post-test, and then there's the difference after they get counseling and a drug. The third group is 8 people, and they get counseling and a placebo. And so we want to see, is there a difference between these 3 groups? What's the null hypothesis? There's no difference. They all end up the same, right? But we want to see, is there actually a difference? And so in SPSS, we're going to use ANOVA. One of the assumptions of ANOVA is that these are all independent groups. Again, you can't be in counseling only and also in counseling and placebo. These are all different groups of people, okay? All right, so in SPSS, I have to set up my SPSS. Okay, I have to pull it up. One second. Okay, here we go. Okay, so I have to go into the grouping variable. I have to go to variable view, and I'm going to call the first variable group. And the values are group 1 is counseling only. Group 2 is counseling and drug. Group 3 is counts and placebo. Okay, and then the next variable is score. Okay, so this is what I have. The group variable is score. So I have 8 people in the first group. I'm going to go grab their difference score. So I wanted to show you that. So I'm going to grab this right here, the difference. That is this right here. I just moved them over there for simplicity. So I copy it, and then I go back to SPSS, and I paste their score. Then I'm going to go grab the other. I'm going to go grab group B, counseling and a drug. I'm going to type, and I'm going to go to group C. Oops. And remember, if I walk away from my data, if I were to walk away and go get a veggie burger, and I thought, what does 1, 2, and 3 mean? I can always click on this button right here, A1, and it'll reveal what those groups are, what the group names are. Okay, so the next thing I have to do is I have to go up to analyze. I'm still comparing means, but now I'm using a one-way ANOVA. It's called a one-way ANOVA. And so I click on that, and I get this box right here. This box pops up right here. My grouping variable, when you move to ANOVA, we no longer call it the independent variable, we call it the factor. So the factor happens to be the group that you're in, right? Because that's the independent variable. The independent variable is counseling, counseling and a drug, counseling and a placebo. The score goes over here with the dependent list. Then I hit OK, and I get a printout. And it looks like this. Okay? So the F is the equivalent of the T. This F stands for Fisher, because Fisher was the one who developed this. And I failed to mention that this was actually developed for agricultural purposes. So my little vignette about tomato fields is right on. So this is an F of 6. I want to know, is this significant? I go over here. If this is less than 0.05, this is significant, and I do what? Reject the null hypothesis. So what is this saying? Is there a difference between the tomato fields? Yes, there's a difference. I reject the null that says there's no difference. There is a difference. However, I don't know which group differs from which group. I just know that there's a difference. And so a group of mathematicians came along and they said, hey, this is a really good statistical test. It tells us that there is a difference between the tomato fields, but I don't know which one is which one. Which group is different from which group? So I purposely left that step out because I want to go back and I want to show you what we have to do. So what we have to do is we go to Analyze again. I go up to Analyze. I say Compare Means, one-way ANOVA, and I get this box right here. And it's already got these moved over. But what I have to do is what's called a post hoc test. A post hoc test. And so I click on post hoc, and these are all different tests that will tell us which group is different from which group. So for example, this person, Bonferroni, is a mathematician, and he developed a post hoc test. Scheffé, Sidak, Duncan, Tukey, etc. These are all of these different tests were developed because it depends on like various properties of the data. A good all-around post hoc test is the Tukey test, developed by John Tukey, who's a mathematician at Princeton. So I always just, if I'm not really concerned about certain things, I just pick Tukey. I hit Tukey, and then I want to click on options because I want to have a means plot and I want to have descriptive statistics. Then I hit OK, and I get my printout again. And here's my printout. Okay, so there's a little bit more to it than the other one. I still have this here, the same F that tells me it's significant, right? It's 0.007. But now I asked it to print out the means, the descriptive statistics. So for example, the difference in the score pre-test, post-test, the average difference for people that only got counseling was only negative 1.75, not much of a difference. For people that got counseling and a drug, they scored 11 points different. So they did a lot better on counseling and a drug. The people that got counseling and a placebo, not much of a difference either. So now it's kind of obvious what is making the difference in this equation. Now what I can do is I can go to my post hoc test by Tukey, and it will show me which groups are different from which groups, or which group is different from which group. So what it does is it goes, okay, counseling only compared to counseling and a drug is significantly different, right? Counseling only and counseling and a placebo is not significantly different. This is going to sound funny, but if counseling only is different from counseling and a drug, counseling and a drug would be the same comparison as counseling only. So this comparison right here is the same as this comparison. It's just flipped. That's just the way it prints out. Okay, so what we see is counseling and a drug is significantly different from counseling only and counseling and a placebo. So what I've learned is the difference is the counseling and a drug. That's the one that is making the difference. And if I can't follow that numbers wise, I created what's called a means plot down here, which will show it graphically in just a second as it pulls up. Come on, SPSS. There's my means plot. Counseling and a drug is significantly different from counseling only, and counseling and a drug is significantly different from counseling and a placebo. But one interesting thing we saw was that counseling and a placebo is not different from counseling only. Okay? All right, so that is ANOVA. The last thing I want to show you, does anybody have any questions? No questions so far? Okay.
Better
last-
ask questions because it's going to be on the test. I'm just kidding.
Uh-oh. Okay, the last thing I want to show you is super easy, super fast. It's just correlation. It's a correlation. But I want to show you how to read it. Okay, so here's my last vignette. Okay, so suppose you work at a stop smoking clinic, right? Stop smoking clinic. And at intake, you ask people, you have a hypothesis that people that smoke have a lot of anxiety behaviors, right? And so you ask 26 people on intake, how many cigarettes do you smoke? And how many anxiety behaviors do you have? And so anxiety behaviors are things like, biting your nails, upset stomach, rapid speech, pain in your back, etc. And so this is how many cigarettes per day, and this is how many anxiety behaviors per month. And so you want to see, are these two things related? Do they go together? The more one you have, the more the other you have. Or conversely, the less of one you have, the less of the other you have. So when we're doing correlation, correlation is scored on a continuum. It goes like this. 0 to +1 to -1, okay? And so if something is perfect, or if something is positively correlated, the more of one thing, the more of the other. If something is negatively or inversely correlated, the more of one thing, the less of another thing, right? The problem with correlation is we can't tell which one, there's no causality involved. I don't know if one thing is causing the other, or do people smoke because they have anxiety, or do they have anxiety because they smoke? We don't know. Now, by convention, if something is, say, like a 0.3, that's a weak correlation. A 0.5 is a moderate correlation. A 0.8 is a strong correlation. Same thing, -0.3 is a weak inverse. -0.5 is a moderate inverse, and -0.8 is a strong inverse correlation, okay? So let's set up our SPSS. It's really easy to run a correlation in SPSS. So let me clear this out. Okay, so here's what we do. Here is what we do. We go to variable view and we say SIGS and we say anxiety. Oops. And then all we do is we put the data in these two columns. And you already saw the data, so I won't show you how I did it, but I'm just grabbing it. And notice the data are right next to each other again. We don't have to make a grouping variable. Okay, can everybody see that? So all we do in SPSS is we say analyze and we hit correlate, and it's bivariate. There's two variables. And then I get this little box right here, and I just put both of them together. And I'm going to do a Pearson correlation coefficient, because Pearson is the one that developed this statistical test. His name was Carl Pearson, so he had a good first name. He didn't spell it correctly. He spelled it with a K, and he had some very, very, very strange ideas about human beings, right? And so his research on correlation has had a lasting and profound effect, because we run correlations all the time in research. But he had really strange ideas that were used by not very nice people, by horrible people. But his name was Carl Pearson. So we're going to hit OK, and we're going to run this correlation. And here's what it looks like. So we look right here, cigarettes and anxiety. We compare cigarettes and anxiety, and it is correlated. And the Pearson product moment or movement is 0.807. And it is actually significant. It's a significant correlation. And it is also what? Weak, moderate, or strong? At 0.8, where is that on our
Strong.
board over here? It's right here, right? So it's a significant correlation, and it's strong. Okay. All right. Does anybody have any questions? And I end with correlation. Correlation is super easy, but like I said, I started out by talking about Kaiser. So there's a correlation between high cholesterol and heart disease. There's a correlation between obesity and heart disease. There's a correlation between blank and blank. And so we run correlations all the time to see if things go together. And also, they're very helpful in building models, right? And the correlation is actually based on z-scores. So just to backtrack a little bit on this vignette, kind of in conclusion. So the way that we ran a correlation was we took this data, and the computer ran it through a formula and converted everything to a z-score. And then it did the same thing with these. It converted every one of these to a z-score. And then it compared the z of x's with the z of y's, right? And so that's why it's important to kind of start with the very basics of, and how did we get a z-score? We figured out the mean, we figured out the standard deviation, etc. So in conclusion, that's why this is also important. All right, does anybody have any questions about God, nature, reality, statistics, food, clothing, shelter? Ask me a food question. Nobody?
What's your favorite food?
That's a good question. It's probably going to offend people. I love prime rib. But you want to know what else I love? Is branzino. I think it's branzino. It's a fish. It's like a white fish. Does anybody go to Vegas? I know nobody goes to Vegas anymore, but in Vegas, there's a restaurant. Does anybody watch Cake Boss, but with Buddy V? So he has a restaurant at I think it's the Palazzo, and it's called Buddy V's. And he has the best branzino. I think it's Mediterranean sea bass, but it's delicious. I had a piece of lamb the other day that was incredible. And I've been eating way too many oysters. I don't know why. COVID. It's COVID. Any other questions? Food related?
I don't have a question, but I was going to add a restaurant to your San Diego
Yes,
repertoire. It's
please.
actually in Carlsbad, but it's called Gonzo Ramen. And it's the best. I used to live in Japan, and it's the best ramen I've had outside of Japan.
Okay.
And the
one of the owners, she is from Okinawa, so it's legit.
Oh, awesome. Awesome. The last time I was in San Diego, I ate at an Afghan restaurant called, I think it's called Khyber Pass.
Oh, yes, at Hillcrest.
Yeah. It was unbelievable. And I think it was the first Afghan restaurant in the United States. So good. Anything else? Thank you for that, Emily. Gonzo ramen. Nothing? I'm done?
You're done. You're early.
Yeah, this is a long day too.
I know. All right,
Nothing
ladies
else?
and gentlemen, are you sure you don't have any last questions for him? As always, Dr. Reynolds, you're awesome. I appreciate your time with my class. It's always entertaining and eye-opening. Any other questions, everyone, before he
Good, thank you.
goes? Okay, I'll catch up with you. Maybe
Absolutely.
next week
Yep.
for sure. Okay.
Perfect. All right. Thank you, everybody.
Bye. Thank you.
Bye-bye.
All righty. All righty, everyone. I know it was a lot of information today. I know it is, but he is one of the best. He makes it understandable and real, and that's what's great about him teaching this class. You know, statistics, as he said, it really doesn't become real unless you do it and it's your data. When it's your data and you've collected it and you've analyzed it or you input it, it becomes real and you get it really good. But unfortunately, you're not there yet. What we used to do when we pre-COVID, you all had computers and we all give you data sets and we would just play with the different data sets and for you to help understand what how to compute it and the elements of them, and then what were the outputs? You know, what does it mean? Since we've been on COVID, we haven't been able to do that, but at least he was able to show you. But that's really the reason why I needed him to show you how to do it. And this is going back to the beginning as to, you know, the nominal, what's nominal interval ratio data, because that will determine the type of statistics that you will use according to what you're trying to show. Okay. All right, so let's go ahead and do a 15-minute break and then come on back. We'll do a couple of activities and then we'll call it a day. Okay, so 15 minutes and then come right back.